Hello everyone, welcome to this video. Glad you're able to join and watch this amazing video. This video is all about Delta Lake change data feed, as you can see in the title of this notebook. So first of all, what is Delta Lake change data feed? So Data Lake Chain Data Feed is a feature in Databricks that basically helps us to track the row level changes between versions of a Delta table. So when enabled, we can see if a record's getting inserted, updated, or deleted. Just like you have in a change data capture tool that reads the logs of a relational SQL database. Now, why is this important? Why do we even care? Why am I making this video? I'm making this video because this change data feed can actually help optimize your ETL pipeline, especially if you're using the Databricks Delta Lake House. And not only can you improve your ETL performance, but you can actually make it more streamlined and you can have benefits of knowing what records change, doing more with this metadata, and all that. So now let's go to the actual demo. Like, this is kind of like a use case that is actually a real world use case that I'm working on in my current project. And I just wanted to use that to demo this feature because this is something we can actually apply in the real world. Yes, so let's talk about the architecture of this demo or this use case that I will be describing. As you can see in the real world use case, I have a source SQL database. This could be, so for example, SAP or SQL Server or Oracle, whatever you can imagine. And we have a CDC tool that we are using to propagate the changes or the transactions that occur on our source database into our Delta Lake landing container or landing zone. So when a user creates a new record into the database, updates or deletes, the CDC tool propagates those changes and drops those files as, let's say, JSON or CSV files into our landing container in our Delta Lake. Now, once we have those records, what we do is we process them, so we get all the records that we have available within a given batch that the ETL runs. We take out all those records, we get the latest version of each record based on their business key. We propagate that to the raw zone container where we do a merge upsert. So imagine, let's say day one, we had a full load, the complete refresh from a table with like historical data. We can push it from landing to raw, but the next batch of records, let's say that while we have to run, we run our pipeline every 2 hours or 1 hour, it's gonna take only the delta, only the changes from the last time and propagate it to the raw. And that's where we have to do a merge upsert logic to apply those changes to our raw container. Once that is successful, we archive those files from the source that we just processed into the raw. We send it to an archive folder. Now we also have this refine container or refine zone that we also need to propagate the same data changes or maintain a table which is pretty much a copy of the table in the raw zone. Now, this is because we want our business users to access our data lake platform only from this refine zone. We don't want them to access the raw. We have a couple of reasons why we do that. Because from the raw to the refine, we sometimes have some logic, some cleansing logic, some logic to maybe combine some few tables from the raw into the refine. So that is why we keep a refined zone separate from the raw, even though that is the same table that we want to propagate. Now, we currently, in this use case, how do you push the changes from your raw to the refine? Or how do you refresh this refine? How do you keep it to be in sync with the data that is in the raw? So there are multiple ways. One is you can do a full refresh every time by copying the files in the raw, overwriting it to the refine. But if you do that could work, but that would be very slow because this could be a very huge tables you have in your raw, and doing a full refresh every single time takes time. Now, can you do incremental? Yes, you can do some delta, only propagate the delta changes or the incremental data sets. But how do you do that? You can have if you have a last modified date field in your raw tables, you can use that to propagate to the refine. However, that requires you to filter the data lake files. For a big table, that takes time because the Databricks has to open those files or multiple partitions of the files to find the actual records that were last modified based on your given parameter to propagate into your refine. So that takes is better than the full load, but it takes some time as well to filter on the last modified date. So that's why Databricks gave us this option, the change data feed. And the advantages of this is that we don't have to now go to that big table and start filtering only for those few incremental changes, or filtering for the files that belong to those incremental change data. We can now have a separate folder that has all the changes. It's different from our main table. This folder will just keep track of the changes in our data lake, which I will show you. And that is only the place we need to read to capture the incremental files. So this makes it really fast. In addition, if we have someone that goes in and directly deletes data in our raw zone, we can also keep track of that with change data feed. So that's the two main advantages we get: the speed and the ability to track deletes. Now let's go into the demo. As you can see, first of all, I have my data lake. I have my three accounts. I have the landing zone. It has the input archive. For today, I'm using the employee table, table for the demo. As you can see, our imaginary change data capture tool has already pushed the full load CSV file and the incremental. Again, it's very simple file, and the incremental file as well. So we have these two files, as you can see, sent to our Delta Lake. Now, what we want to do is to propagate them to the raw, which, as you can see, has nothing yet, and refine. So first of all, this is the notebook. To use Delta Lake change data feed, we need some prerequisite. First, we need to create an external table on the Delta file that we want to track. And also we need to run a statement to enable the change data feed for that Delta table. And in this specific scenario, this can apply for an existing, let's say you have an existing pipeline that is currently transferring data from the raw to the refined container, but we want to optimize it from using the last modified date filtering of files to use the change data feed. So this can also work in that scenario. So first of all, we're gonna do what? We're gonna run this. Yes. Now, as we have explained, this is the prerequisite that you need to apply on your Delta Lake tables for you to actually take advantage of this feature. So we have our cluster is running. We can run this import statement. I will upload this notebook to the GitHub link for reference as well, so you can use this as a template in your real world application. First of all, we have the full load, like I explained. Like any pipeline, you have a full historical load refresh, then comes the incremental load. So this is the logic. It's very simple. We read from the input file. Next step, we create a timetable view because I love SQL. I don't really enjoy PySpark. And this is the SQL logic that we use to basically first to get the schema in order, or default. We basically default the full load last modified date to a 1900 date, and the transaction type, we default it to insert, because like I showed you, in the full load doesn't have those metadata fields, but the incremental does. So we try to default it to some values so it can make sense in when someone looks at it. And then the next part is to get the last or latest version of each business key record based on the last modified date. Because as you can see, sometimes with the changes, you can have multiple versions of the same business key record. Let's say our primary key is ID, so we just want the latest version of the business key record. So that's pretty much it. So we run this command, and we drop the row number field, so it's running. So that ran well. We can display the data just so you can see that it works properly. So this is our data. Now, next step is we wanna now move this data to our raw zone. So we wanna move this data to our raw zone. So we're gonna run this statement. As you can see here, you can parameterize this load type in your production ETL to tell it which one to run. You see, in this case, I didn't want to create two different notebooks. I rather wanted it to be all in one notebook. So I will pass in a parameter. If I want to do a full load, I will tell it to run the else statement. For incremental, it's gonna run this. For now, it's gonna do the full load because this is the first time running it. I'll run it. And one thing I also want you to realize is when we did this step, it created in our raw zone, it created this delta log table and created a folder so that it can actually start tracking the changes. So as you can see now, we have run this and we wrote data into the raw. We can do select star from this. As you can see here, we have it done. Actually, did I run this? I don't think I ran this statement actually. My bad. Let me run this. That's why I didn't see the... Okay, this is because I already created a table yesterday during the demo, during my own personal demo. So I'm gonna drop it. But if this is your first time running this, when you run this, it should work since you don't have this table created in your Hive meta store. So again, the first step is create that table, register it as a Delta table in your Hive meta store, which I just did again to be safe. And if we look at it right now, we can see the Delta log is tracking the changes while this is the actual file. So let's go back to where we left off. So we are right here. We check that the data came from the landing zone and successfully got written into the raw zone. Right. So this looks good. Next step is we will move the data from the input folder to the archive to free up space so that the next incremental record will flow in, right? And all these things, I'm doing the very bare minimum, to be honest. When you are doing this in the real world, you have to think about making sure that when you run this archive, you are not moving files that you haven't processed already. So one thing we do in the real world is to capture this list of files beforehand, before we run uh, the notebook, like from the landing to raw. We capture the list of files that we are about to process, like from here, actually, sorry. We capture those list of files, and those are the list of files that we will use to move it to the archive whenever we are done processing from landing to raw. So that is all good. So we ran that, and we can see in our landing zone. Sorry guys, I forgot to push this little clearer. And in our landing zone, we can see we have moved those files into our archive. You see that? Now, the next step is to try to see how we can leverage this Delta change data feed. So one thing I want you to know is this describe history table is really important for us because it tells us the versions of the raw table, because this is the raw table that we're gonna use to know or to query the change data. And I will explain that in a bit. As you can see, so far it has version 0, version 1, so which is good. In this case now, we are going from the raw to refine. Again, since this is our first time running this is not gonna run the full load part, the incremental portion. It's gonna run the full load portion. And this is another idea I just throwing it out there is, if you want to know if you should do a full load, just check if the table is exists as in your refine. If it's a delta table exists in your refine folder, know that it needs to do an incremental, else it probably needs to be a full load. So as you can see here, I'm gonna run the full load, and first step is, after we have enabled those basic the delta changes like we already did, we want to use the change data feed. We need to capture, right? If we want to use this change data feed, we need to capture the version number and use it as a watermark for our incremental. This is very important, guys. So if we want to know how to basically capture the incremental records, we need to know where we last stopped, right? Like I showed you here, if I want to go the incremental, and for me not to get the records I already processed. I need to know that, okay, go from the last version that I last loaded into my table to the most recent version. So what I'm doing here now is I'm going to this history table, querying it, getting the max version number, and I'm storing it into my refined table. That way I know where I last left off. Now in this step, all I'm doing is adding the metadata fields that we're gonna see when we uh, query the change data feed. Let me show you. Right here, if you look in the official documentation, you're gonna see the same. When you query the change data feed, you will see these are the additional metadata fields. So what I'm doing right now is, even though I'm doing the full load, I'm also creating these fields so that when I do incremental, I'm able to track it as well. So in the full load, I'm giving them default dates, but this is very important. I'm giving the max version, giving the current timestamp, and I'm writing it to the refine zone. So let me run this node. Yes, I'm not quite sure what is going wrong with that, with the exist function, but for now, we can just rely on the load type. Again, like we did it earlier, we are passing in this as a parameter to decide if we run the incremental version or the full load version. So let's run this. As we can see, we are running this we are writing it to the refine. And when we do our refresh, okay, I see what's wrong. We have a refined. We have a refined name, not refined. Okay, I see what is wrong. All right, how come I missed that for so long? That's funny. All right, it's all good. Let's run that again. All right, when we go back here, now we see our table. Sorry guys, I missed the letter D. That's why it wasn't working. Now, this is what we have. This is literally what we have. Now we have created this data set from the raw. We wrote it to the refined. And we can confirm that, again, it's the same data set we expect. We see the default columns that we have added. The max update version, commit version is this. So we're good to go for the incremental. So full load is done completely amazing. Now let's run the incremental. For the incremental, what the first thing I will do is I'm gonna drop a new file here to simulate imagine the change data capture to drops new records. Nope, I don't think this is the right. This is not the right file, sorry. I want to upload a file, yeah, this 2023 file. As you can see, it's uploaded. So this is the incremental file that with some data. Let me show you the data. It just has 2 records. One is, it has a James, an update, and it also has a brand new record that we need to insert. So now when we run this notebook, we don't have to run this part again because we already done it. So for the incremental load, we can run this by first running this portion that reads the data from the landing zone and gets the latest version of each business record. So again, I've run that, and you can see here our source table data set is these 2 records. It got the latest version of the record, and we will use that. In this case, I'm running the incremental. I'll change this to I, and I'll run this pipeline. So basically, it's gonna run the incremental portion. So what it's doing is gonna do a merge upsert using the source. This is our source data frame, and our target is what we already have in the raw zone. It's gonna merge on the primary key. When matched, update all. When not matched, insert all. So that is what we're gonna do. So we should see running merge. It does this merge statement. Shouldn't take time. That is done. Next step, let's validate that. As you can see, our new record is here. James got updated to the latest weight. Now, like we did before, we're gonna move, after successfully going from landing to raw, we move the input records to the archive. Now let's check our history for the raw. As you can see, now we have this version 2. This one has the changes. This version 2 has the changes, and we need to query for this. So we'll see. So after knowing this, again, we run this part. We run the incremental. So for the incremental, we know that, let's break this down. First is we are reading from the refine, which is our target. This is very crucial, guys. We get the last commit version, the max of the last commit version column, which we already know in this case is 1, because that will tell us where we last left off. And then we run the describe version for that table. We get the max. version, which is telling us the latest version that we have in our raw table when we look for the changes. That way we know the the first we know the left interval and the right interval. And then we're gonna try to retrieve the changes from the last commit version in our target to the latest version in the change data feed table. So this is the syntax for the change data feed, guys. So change data feed, the way it works is you run a select statement and you have to pass the table name, the delta table name. You pass the version you want to start from and the version you want to end from. And you're going to see it here. So if you wanted to go to get the records, only the changes that happen from version 2 to version 5, you can run it. If you want from version 3 to version 5, you can run it. So the goal is we don't want to process the records that we already processed. So that's why we need to know where we last processed, which is what I'm doing by getting that from my target. I'm getting the max from my target. I know where I last processed. And now I also need to know the latest place, the end point I need to go. Because if you don't get these values right, it will not work. You need to get passing the exact values into this query. And once we do that, we also get the last latest version of the records based on the primary key. We don't want this pre-image, so we filter it out because it's not useful for us. We just want the post image of the update. And we now drop our row number and then use that to do the Upsert. So let's run it. So I can see it's running the merge. So it's doing its magic step by step. As you can see, it's finished running. Again, what it's doing is it's going directly. When we look at the raw zone, we can see this change data. It's no more going to these files, opening them and looking for the last modified date. No, you just go straight to this change data. You see, it's only one file. It's very simple for it. It knows exactly where to go and grabs those changes. It doesn't have to go for each and every file to figure out the last modified date. Because like you see, there could be updates on these tables and all. So we are making things more efficient by using this change data feed. So now, as we have run it, let's confirm that it actually did what we expect. And we see, wait, did it run properly? Fine. So nope, it didn't run properly. Something is wrong. Because in raw zone, we should have Kennedy. Let's check. Let's check if this is correct. Again, the demo gods decided to speak. So raw zone, we know it's version 1. let's see, let me check here. This is version 2. You can see here, this is what we should have got, right? So not sure why. Okay, I think I know what's wrong. Yep. Again, I made the mistake. It should be refined. That's why it didn't work properly. So let's run that. Let's run that again. Let's run that again. It didn't really merge properly because the folder path was wrong. So I have to change it to refined. And there you have it. So you can see now it's correct. Now we're getting the latest changes into our refined table. So that's about it for this video. If you made it through, great, amazing. I hope you learned a lot. This is how we implement change data feed in the real world with production level code that you just need to tweak a little bit, parameterize a little bit. As you can see here, we can do a lot of things. We can parameterize the table names, make this a dynamic pipeline, and use it to as a framework to process our data from our landing zone all the way to the refine. So depending on the way you want to design it, you can customize this as much as you want. So that's about it for this video. If you have any questions, drop in the comment, like, subscribe, share, and I'll keep it coming, guys. Have a good day, and thank you.